You have the capability either for different verticals, for smart meter, automotive, healthcare, and so on, to manage this connectivity. The benefit of the eUICC is that for device maker and service provider, it helps you to manage the group of devices. You don't need to send people physically to change the SIM and put it through.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. Managing SIM cards across global IoT deployments has long been a logistical nightmare. Different carriers, various regulations, physical swapping requirements. The connectivity landscape remains frustratingly fragmented. Today, we explore how embedded universal integrated circuit card technology changes this entirely. Gregory Laloy, IoT Product Line Director at Thales Digital Identity and Security, joins us to discuss how eUICC eliminates physical SIM management and enables remote carrier provisioning. We will discover how this technology transforms device connectivity, enables new use cases, and simplifies what has been one of IoT's most persistent pain points. I'm really to have you on the show, Gregory, so let's dive right in. And can you introduce yourself and tell us what drives your work in IoT connectivity?
So thanks, Ruth, for the invitation and the opportunity for us to be present in the podcast with you on discussing the eSIM technology. So indeed, I'm Gregory Laloy. I'm responsible for the IoT product line within Thales DIS. Within this group, we have, as you said, hardware product. So a regular SIM, as you were saying, that we are selling to telcos. We have also ruggedized SIM for industrial IoT. And we have the eSIM that is coming, the new technology that, as you said, allow, device makers to take control of their devices and the life cycle of their devices. And with Thales, we want to enable this market on the IoT with the eSIM and the technology for, remote SIM provisioning with the new standard that is coming, thanks to the SGP32 standard, targeting the IoT market, where we want to offer a solution to help our customer to dive and grow the business that is really opening in the IoT market, where we see a big boom with this new standard, with the usage of eSIM, this technology, for various verticals within the IoT market.
Terrific. Embedded universal integrated circuit card. That's quite a mouthful, eUICC. For listeners who are unfamiliar with this technology, how would you explain this? What fundamental problems does it solve for IoT deployments?
So, as you were saying, the main problem that it's solving is to have what we call a single platform. When you are a device maker and you want to launch, different product on different countries, every time you need to understand that I have these devices that needs to go in that country. I need to work with this carrier to have, the right SIM or the MIM to embed directly in my device in this location. And that's the same depending on the locations where your device needs to go. Because when you are a device maker, you produce a lot of devices for different countries, so different operators that you need to work with. Embedding an eUICC that can be soldered directly into your product will help you to facilitate, the production, the industrialization of your devices independently on the country, because then, thanks to the connectivity management platform that we have as Thales, that we call TAC, Thales Adaptive Connect, we have the capability remotely to push a new profile depending on the countries where the device will end. It will connect. It will have the capability to provide the first, local connectivity in order that when he will reach a country, he says, I need to be in that country, for instance, in Brazil. He will connect and then he will download a new profile, the operational profile, that's what we call, in order that the device can run with the local, the local profiles and everything that will be required locally for this device to be up and running for the device maker and the service provider who will use it.
But it's not like an electronic SIM, right? What changes for device manufacturers? You mentioned that you solder it directly onto the board or chip.
That's the same thing as what we experience on the consumer market. It's the same a little bit on the consumer market. In the beginning, you were used when you wanted to change a phone or from an operator to another operator. You were calling the operator, the new operator. You say, I'm a new subscriber. I have a new phone. So you were taking your SIM, your physical SIM from your phone. You were removing it and putting it in your new phone. Either you were changing phones, or if you were changing of operators, mobile network operators, you were contracting a new contract with a new operator. He was sending to your home a new card, and you were just installing this card, which is a physical element as well, into your new devices. With the eSIM, we have a form factor also that is there. It's a solder SIM that is inside your devices. It means that all the physical that you were receiving from the traditional SIM, from this form factor, has changed to this new form factor where it's already integrated into your mobile, if I'm taking this example, and through what we call QR codes, or with this eSIM technology, the thing that you have to do is that you need to, with the mobile phone, it's easy. Generally, you receive from the operator an activation code, a kind of a QR code. You scan it through the Wi-Fi of your phone, then you scan it, and then you will download the new subscription on your phone directly in your phone. So there is no need for you to have access to this physical SIM, for instance. But in the IoT market, which is thanks to the SGP32 standard, what I was referring on the consumer, it was based on the SGP22, it's more or less the same. We are using this eSIM technology, but as it's IoT devices, we don't have, as smartphone, the capability to download or to scan a QR code. Therefore, the SGP32 standard, thanks to the platform that we are building that is called TAC, Thales Adaptive Connect, allows with a UI that is cloud-based to initiate those activation codes and then push it to the device.
Okay, makes sense. Then what happens when your device needs to connect or switch carriers?
As I was saying, during the manufacturing process, most of the time, we need to have what we call a bootstrap. It means a first connectivity. When your device will start the power on in a certain country, it will say, I'm here. I already have a connectivity that is present. The device will connect to what we call, thanks to the SGP32 standard, an EIM. So it's a platform to manage this connectivity that we call TAC at Thales. And then we will differ through this platform with a kind of a ruler, eSIM orchestration layer, if you want, or a fleet management. We will say for each group of device that will connect with this range of devices, we know that when they will land in France or in Poland or in UK, they will need to download a specific profile. So during this time, the platform will say, you are device A, you need to get this specific operator profile for these specific countries. It will download it. And then this new profile will become what we call the operational profile, which means the one that will be always active for the device to interact and send data to the device management platform or to the service provider to collect the data from his IoT device.
And how do you ensure both device and network security? I can imagine that that's a consideration you have to make when things are remotely programmable.
That's a very key point, especially when we see all the new regulations that are starting to pop up. So in Europe, we had the RED, we have the CRA, the Cyber Trust Act, exactly, that is coming. In the US, we have the US Cyber Trust Mark also that will be there. And we see more and more regulations that are asking security is starting to be very important. So indeed, in terms of security, we have, let's say, different fronts. First, our hardware is GSMA certified, is ESA certified. So it's showing that it's a root of trust that has a lot of security measures that is inside. Then the platform that we have and that we are building is also certified by third parties. But we need to think to the overall ecosystem. And the benefit of using an eSIM, the eSIM is what we call the root of trust. It means it can be the foundation, the hardware foundation of the security of the device that you can use. So not only for the connectivity management, but also for the security lifecycle of your devices. Meaning that you will have the capability remotely with a platform as well to manage those credentials or security lifecycle of your devices using the eSIM as the root of trust. So at Thales, cybersecurity is one of the key pillars that we have on top of connectivity. And that's why at Thales, we are bringing this connectivity and security management platform to help our customer to navigate and have an easy solution that we can say, it's not the right word, but the way I want to say it, it's something that easy to deploy on connectivity and on security, because we want to remove this burden, because there is a lot of things to do when you deploy an IoT project. So, but we want to make sure that the device is secure, the device has a strong identity, it will be the right devices that will send all the right data to the application server from the service provider to take decision if he has to take any decision depending on the data that he's collecting from in the field.
Let's dive into some use cases. Are there specific use cases that become only possible with eUICC and that they weren't possible before?
I think today, most of the use cases were a bit the same. Independently of the form factor, you have the capability either for different verticals, for smart meter, automotive, healthcare, and so on, to manage this connectivity. The benefit of the eUICC is that for device maker and service provider, it helps you to manage the group of devices. You don't need to send people physically to change the SIM and put it. So, for instance, in extreme condition, oil and gas, or you want to put your tracker, let's say even on the technology, either cellular, not cellular, but you want to have something that is for remote monitoring, you don't send everybody every time because it has a cost and so on. So the benefit of what this eSIM is providing also, not only for the manufacturing process, but also for all the maintenance of your device during the lifetime will ease a lot of the operations from the service provider who are operating those devices in the field.
Yeah, that then makes it obviously not only faster, but also you will save some costs on your maintenance team, and it will probably be safer because you can react really quick, right?
Exactly. So cost it's an important factor, because in the end, indeed, you manage remotely those operations. In the past, you were selling technicians and so on. And also the benefit of IoT and where IoT is booming is to have the capability to try to act remotely in order that you can take, let's say, actions or decisions, let's say, in a faster way.
I'm sure you might not be able to tell any customer names, but can you share a concrete example, maybe explaining a little bit of the setup and the benefit and outcomes?
We have various type of customers within Thales. So if I focus on the IoT, we are working with some leading MNOs in the US or in Europe, but also in Asia. We also are working directly with device makers that see a strong benefit on some verticals, the usage of the eSIM, and also service providers that can be from the smart meter world or from track and trace or from healthcare, where they see the benefit of the usage of these solutions from all the things that we said in the beginning. To have cellular connectivity, it's important because of the global coverage that you have. The technology of the SIM allow also the device maker and the service provider to choose the connectivity that he wants, to streamline also the process for the manufacturing, but also remove a lot of complexity, as we were saying together in a few minutes ago, all the logistic and the maintenance of his device when all those devices are deployed in the field.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or afnet-silica.com. That's avnet-silica.com.
So you said automotive, healthcare, industrial appliances, even big oil platforms would benefit probably from a remote thing, you said. And within automotive, I suppose that also means driverless cars, or what is the use case?
So I think today the example that we can make, let's say for any service provider, for instance, resiliency, it's important. You are in a country, And on some countries, potentially a network will work better than another one. So with this platform, you have the capability remotely to say, okay, maybe the network that I have is not good enough for the device to send me data. I will try a new network like that. I will push a new, let's say, operator profile in this device to collect the data. Also, most of the time, even if we have a lot of very nice coverage in each countries, some operators are better positioned in some specific regions. So with this platform, you have the capability. For instance, you are, let's say, working on an asset tracker. You use it in some countries. You can definitely change from one option from one country to another. Let's focus on this asset tracking, for instance. If I take the example, you are using currently a device, depending on the technology of the cellular technology, and because there is a lot of technology, it can be 4G, 5G, narrowband IoT, Cat M1. But for instance, independently of this, let's say cellular technology, you are doing a device and your device needs to run in France, in UK, in Italy, in Germany, in Switzerland. And you have different operators, even if some operators, they have what we call roaming agreement with partners, potentially you want, because of cost also, you want to have a dedicated local operator that will support it. So with this platform, you will have the capability to make agreements locally. And then with the same device, same platform, each device will run with the local operational profile in each country you will select, and then you will contract with the local carrier.
Okay. Cool. That might be a service provider like Orange who operates in many different countries that would be interested in this.
Orange can be interested also, let's say for his customer, to say you want to have a solution that is IGP32 compliant. We have something. So the benefit of this solution for the IoT, it's for all IoT value chain. It can be for MNOs, MVNOs, device maker, but also service providers who are the one in the end who are managing those devices. This system can apply independently of not the vertical, but let's say the different actors in this IoT ecosystem. It can be a benefit also indeed, as you said, for let's say MNOs and MVNOs, but also service providers and device makers.
Fantastic. What should developers know about integrating eUICC into their IoT devices? Are there specific technical requirements?
How can I say? Most of the time, when you are working, let's say on the cellular ecosystem, you work with what we call modem makers or module makers. The people like the Thales and these kind of, let's say, companies that in the end are integrating these modules with the modem, with the chipset to provide the cellular connectivity. And most of the time, device makers are integrating directly these modem capabilities inside their, these modules directly into their devices. The benefit of working with, let's say, modules maker is that when it's done, then you integrate it into your platform and then it's easy because they do some certification, they integrate everything. So that's one of the benefits working directly. And some device makers, they want also potentially, depending on the technology, to integrate directly the eUICC on what we call their main PCB, their main board, then to select different, let's say, modem makers from the market. I will not say it's something that is easy or difficult. It depends on the level of expertise that you have. But then it's connectivity. So you need to have some experts on the RF, on the design, on the layout, and all these kind of things.
And we have already mentioned that the total cost of ownership is very attractive. The lower operational complexity makes it very attractive. And I read a study, I think that also you published, that eSIM connections alone are projected to exceed, I think, 4.5 billion by 2027. So this is not just a trend or an emerging tech anymore, right? It's becoming a serious foundation for IoT deployments worldwide. What's driving companies to make this transition? Or do companies still need to be convinced to switch to eUICC technology?
I think, as you said, we see a big trend first in IoT for cellular connectivity. So that's one key thing. We see that the cellular connectivity, it's the benefit that we have on the cellular connectivity. It's mainly for quality coverage, for the device lifetime, also security features I was saying in the beginning, but also to comply with regulations. That's something that's important. And indeed, IoT with the eSIM, we see a big trend in acceleration into this eSIM market. So either the eSIM or the iSIM, the integrated SIM. That's something a bit similar but different. It's something that is integrated directly inside the modem. And the big benefit of using, let's say, this eSIM technology, it's what we said. It's to help manufacturer to simplify this process for the industrialization, but also for the deployment and for the device maker and the service provider also to operate until the long lifetime of the device that will be deployed in the field. From time to time, we have devices that are there for more than 10, 15, or 20 years.
Wow.
So from this lifetime, you need to have the capability to act and change, for instance, if you have any issues. So that's why this kind of eSIM technology, plus also the solution that we're providing on top for the management of connectivity, it's very important because you need to provide the capability with this eSIM technology and the platform to remotely change if you have any issues and also be very conscious of the lifetime of the devices. Some of them, and even most of them on the IoT, are battery powered. So also there is a lot of work that has been done on your side because battery saving is, and the usage of the battery is very important in this IoT, let's say, deployment.
Yeah, we did have some very interesting podcast episode about power management recently. I will probably link them in the show notes, so to make some cross references. That's always interesting. Where do you see this technology in the next coming years? What developments excite you most about it?
I think we are still building this AGP32. It's there. So we really have, let's say, some customers, some pre-deployment and so on, and we see that it's really booming. Where we see a big trend also is in this management of connectivity and security. This is where we at Thales, we want to grow much more to help our customer to tackle the security challenges that they will face for the IoT. Even if indeed you can have local attacks that can still happen, you have also remote attacks. And we as Thales, we really want to position ourselves as a trusted partner on the connectivity and on the security. So we see with the regulations that are coming and that will be deployed soon, post-quantum crypto, it's also very important. And that's something that we are investing also a lot on this area, and a lot of innovation also that we are working with that I cannot really say to provide benefit again on the usage of those platforms for the device maker and service provider to see the full power and the benefit of let's say, using these kind of solutions.
And if one of our listeners now is considering eUICC for their IoT project, what would be your recommendation? How should they start?
Go to Thales first. So if he wants to work on the eSIM, I think that's an hardware that he can purchase directly from Thales. It's something that he can directly design into his PCB. As I was saying in the beginning, modules maker also are there to support, let's say, device maker who wants to integrate this technology into their devices, into their PCB. So that's something that is important and that is there. And let's say there is a lot of factors that can support for this integration and then deployment.
Terrific. I will put your contact information and the resources and necessary links in our show notes and on the podcast page, so everybody can look it up after listening to this episode. Is there anything that I have not asked you that you wish I had asked you?
I think we covered already a large scale of this discussion on IoT. Again, the IoT market, the way we see it, it's growing, it's exponential. We see more and more needs also for this eSIM technology, the combination of connectivity and security. So we see that there is a lot to do in this market. And also the benefit of what we want to see is that we want to address all the verticals in the IoT that have a need for cellular connectivity. So it can be track and trace, automotive, healthcare, security cameras, fixed wireless access. I think we have the capability to cover all the different use cases and different verticals from this IoT market and ecosystem.
Yeah, it sounds really flexible and it has a very low barrier to step into this technology, right? But you have really demonstrated today that the eUICC technology, it really is a mouthful, isn't it? Transforms cellular connectivity and makes it seamless and remotely manageable. Thank you so much, Gregory, for being on the show. It has been truly insightful and great to chat with you. And I hope you enjoyed the episode as well.
I did. Thanks a lot, Ruth, for this invitation and the discussion that we had together on this very interesting IoT cellular connectivity system. Thank you very much for your time.
Thank you. It was really great chatting with you. So thank you for listening to We Talk IoT. Stay curious and keep innovating. This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.